Leetcode 221 Maximal square. Given a num cross n binary matrix filled with zeros and ones, find the largest square containing only ones and return its area. So in this example, we are given a matrix. We need to return the largest square, which is considering only one. So here, these two, which are highlighted in green and red, are the largest square possible, containing only ones. These are all of size 2 cross 2, so our answer will be 2 into 2, 4, since we have to return the area. Now in our example 2, our output would be 1 because we are having maximum of 1 cross 1 area only. In the third, since we have only one element which is 0, we cannot consider that, so our output is 0. Let's try to understand this with the help of an example. Now in this example, this is our input array, so we'll be considering this each by each block and we'll be marking it as the bottommost block. We'll be building this by expanding this towards the left diagonal and upper one. So for this element we are having one, that is we can consider this block. If we consider this block, we cannot expand in the upper right or upper diagonal or right because we have nothing here, so it will be simply 1. Now the second element have 0. Since we cannot consider this 0, so we'll be simply writing this 0 means if we cannot consider this block, we'll be simply writing 0 here. Now for the third one we are having 1, that is we can consider this, but the upper one is empty and also the diagonal is empty, so we cannot expand, we'll be writing here 1. Similarly 0 and 0, because we cannot consider this elements. For here we'll be writing our element is 1, we can consider this element, but in the right we are not having anything to expand, so we'll be writing the 1 here, 1 here, 1 here. So this all will be marking our base cases. Now we will fill inside the array starting from 1th position of the row and column. Here if we see the element is 0, that is we cannot consider it as the bottommost rightmost element because the value here is 0, so we'll be simply putting 0 here. Now here it is 1, that is we can consider this element. Let's name this 0 1 2 3 0 1 2 3 4. So we are now checking for the case of 1 2, its value is 1 in the original matrix, that is we can consider this. If we try to expand this, upper we are having 1, yes we can expand. In the diagonal we are having 0, we cannot expand. In this also 0. So these 0, what do they denote? They are saying that you cannot expand it here because we are having the values as 0. So the minimum of these 3 are minimum of 0 0 and 1 is nothing but 0. Considering this element plus 1, we'll be having 1 as the answer for 1 comma 2, so it will be simply 1. Now for 1 3, which is this one, we will be checking this has the value 1, means this block can be considered at the rightmost bottommost block. Now we will try to build this. Since it is 0, we cannot consider upper here. 1 we can consider, but since it is 0, we cannot expand like this because we cannot take this block to make this entire 2 cross 2. So simply we will be returning the minimum of these 3, which is 0, which is 1 1 1 1 0, which is 0, and we'll be adding this block, which is 1. 1 is our answer. Maximum we can make is 1 cross 1, that is by considering this element only. Now let's try to analyze this for 1 4. Our 1 4 value is 1, that is we can consider this 1 4 element, but in the top we are having this 0. Here also we are here also in the diagonal we are having 0. In the rightmost we are having 1. Minimum of these three is 0. We'll be adding 1 by consider this element, so its answer would be 1. For 1 4 the answer is 1. Now for 2 1 value is 1, that is we can consider this element 2 1. Now we'll try to expand it. We cannot expand it since it is 0. We cannot expand here. We can expand here 1. We can expand here, but to build this whole we require minimum of these three, which is minimum of which is minimum of 0 1 and 1, which is nothing but 0, and since we have considered this block our answer would be 1. Now for 2 2 what we try to do is we'll be checking this block as value as 1, so we'll be considering this 2 2 block. We'll try to expand it. It is 1, yes we can take. The diagonal is 0, we cannot take, and here it is 1, we can take. If we try to expand it, we'll find minimum of this. These 0 is restricting us from expanding, so simply our answer would be minimum of these plus this considered 1, which is 1. Maximum we can form is by considering this element only. Now for this, which is 2 3, what we can do is we can see the value is 1, that means we can consider this block 2 3. We will try to expand this upwards. Yes, 1 it is possible. Try to expand this diagonal. 1 it's possible. Right towards right, yes it is possible. We'll take minimum of these three, 1. We'll add 1. We'll be returning 2 as a count, because we can form this maximum 2 of 2 cross 2 here. Now we'll be considering this 2 4. Now the 2 4 value is 1, that is we can consider it as the rightmost bottommost block. If we expand it, yes we can consider, since it is 1, yes we can consider it is 1. 2, yes is consider it is 2. So we'll find minimum of these three, which is 1. We'll add 1 for this block. We can create 2 cross 2 block. If we notice here that what would happen if we would have been taken this 2 instead of minimum, we have taken maximum. This maximum is saying that you can expand till 2 here, but these 0, that is for this block, if you consider you can expand here till 2, but this one is saying that you are restricted to here only. So if you consider this whole block, this won't be case because zeros are there. So we will be considering only the minimum of these three, which is this block, which is this block here highlighted in purple. The minimum of these three is 1, and considering this block 1 plus 1 is 2. So our value will be 2 here. Now the next is 0. We cannot do anything because we cannot consider this element, this block, as the rightmost bottommost block. Now since it is 0, we cannot consider this element as the rightmost bottommost block. Now this is 1. Yes, we can consider this as the rightmost bottommost block. This 2 we can expand up. This 1 we can expand towards diagonal. This 0 we cannot expand, so we are restricted by this 0. That is minimum of 0 1 and 2 is 0, and we'll be adding this plus 1 is 1. Maximum we can make is this 1 cross 1. Now for the next value, it is 0. Since it is 0, we cannot do anything, we cannot consider this, so this will be our case. So we are getting two 2 cross 2 matrix which are overwritten like this. So this highlighted in yellow one and purple one are 2 cross 2 matrix, which is 4, area having 4. This is our output. Now how do we do this programmatically? Is like this. We will be iterating through this matrix. Now if it is not, if the ith and jth are not equal to 0th, means we will not consider for the 0th row and 0th column, because these cannot be expanded. So we will not consider for the 0th row 0 column, and also matrix of ij should not be 0, because for 0 we cannot consider that element. So other than that case, we can expand. So what we'll do in expanding is we'll try to find out the the minimum of the diagonal element, the upper element, and the right one element. Will be for 13, 14. We'll be finding the minimum of these three, and we'll be assigning +1 to the original matrix. Here we are modifying the original matrix only. Since the original matrix is a character matrix, to find out the current value, I am subtracting it with the 0, character 0. So we'll be getting its integer value. Now, if the current value, which is greater than the global maximum what we want to find, then we'll be simply updating our maximum. After this, we'll be returning our max into max, which is the area which we have found that as a maximum. Let's try to submit this solution. Okay, thank you.